what you have to do is, let's say this client sends the first request. So what should happen is, this particular first request should reach to server 1. Now let's say client sends another request, that is second request, then that second request should reach to the second server. Hi all, this is me Karan. So in this particular lecture, we are going to talk about one of the very powerful project idea. And using this particular project idea, you can improve your understanding around how the client server architecture works, how the communication between client and server takes place, how the client forwards the data to the server, and how the server replies back to the client. At the same time, you will also get some kind of understanding how you can serialize the data, how you can deserialize the data. Let's say in your system, multiple servers are there and multiple users are trying to connect to those servers. So how you can do load balancing so that all the server receives equal amount of traffic. So this particular project idea will provide us the knowledge around all these things. So let's try to understand the problem statement. And one thing I would like to mention, that in whatever language you are comfortable, you can use that particular language to implement this whole idea, because underlying logic is almost same in all the languages. It is just that there is minor differences in the syntax. But if you are implementing this particular idea using C++, that can provide you the maximum profit. So let's try to understand the whole problem statement. So what you have to do is, let's say there is server 1 and there is client 1. So you have to implement client and you have to implement server. So these client and server both will be talking to each other using sockets. And this particular client can send different kind of request to server, and at the same time server can also reply back to the client. So let's say there is this data, struct data, and this can contain different fields. So what you have to do is, you have to send this particular data to the server, and this data will also contain the request type. So what kind of request you are sending to the server, and based on the request type, server will respond back to the client. So how you can send this particular data to server and can receive back from the server is using that serialization and deserialization mechanism. So this data can also be represented using Google protobuf. So this is one of the very powerful tool to serialize and deserialize the data. So you can use maybe Google protobuf, or you can use simple C++ or C struct to send the data from the client to server. So till this point, there is single client and single server in your entire system. So what will happen is, client will create the instance of this data D, and you will serialize this data, and then you will forward this data D to the server. Now server will deserialize the data, and whatever was the request type, based on that it will take certain decision, and then again it will serialize the data and then will respond back to the client, and again client will deserialize the data to fetch the response from the server. Now let's say what happens is, let's say instead of single server, there are multiple servers in the system. So this is server 1, this is server 2, this is server 3. So what you have to do is, let's say this client sends the first request. So what should happen is, this particular first request should reach to server 1. Now let's say client sends another request, that is second request, then that second request should reach to the second server. And if client sends third request, then that third request should reach to the server 3. And let's say client sends another fourth request, then that request again go back to the server 1. So all the servers should serve the request in a round robin fashion. So how you can do this? You have to figure out yourself. Now let's say what happens is, instead of single client, there are multiple clients in your system. Client 1, client 2, client 3, and all these servers are also there in the system. So what should happen is, if client 1 is sending first request, then that request should reach to server 1. If client 1 is sending second request, that request should reach to server 2. So this entire mechanism for client 1 should take place in the round robin fashion. Similarly, for client 2 also, you have to make sure that all the requests are reaching to all the servers in a round robin fashion. So how you have to do? You have to figure that out yourself. So one of the ideas could be, you can assign some kind of like ID. You can call this as an instance ID. So each server will have a unique instance ID. So let's say this is ID 1, this is ID 2, this is ID 3. So this client should be aware that to which server it sent the request previously. Let's say it has sent the request to ID 1, then it should send the next request to ID 2 and the third request to ID 3. So similar kind of logic should happen for client 2 and similar kind of things should happen for client 3. So this is the entire project idea. So if you implement this entire idea, then you will get to know how the server works, how the client works, how the communication between client and server works, how this entire load balancing mechanism works, because here we are making sure that at a time all the servers are receiving equal amount of traffic. So that let's say there are 100 servers in our system, so we are utilizing all the resources equally. It should not happen that server 1 is overloaded but server 3 is in ideal state. That kind of situation should not happen, because it will add to the latency. So this is the whole idea which you can use to improve your understanding around how the client server architecture works. So let's meet in some other lecture where we'll talk about some other project idea. Thank you.